Dear students, in the previous classes, we have discussed in detail about consumer preferences, how the consumer preferences are represented by using preference relation, and also the axioms about consumer preferences or preference relations. We have also defined the utility function, and using the utility function, we have derived the indifference set and the indifference curve associated with the indifference sets. Now, it is possible to relate preferences to indifference curves. That is, we can associate indifference curves to specific preferences. That is, if preferences are given without defining a utility function, we can specify the associated indifference curves. But we can also represent preferences by utility functions. My point is, you can associate indifference curves to specific preferences. You can also represent preferences by utility functions. Suppose that you are given a utility function xy. A utility function xy is given. If a utility function xy is given, it is easy to draw the resulting indifference curves. It is easy to draw the resulting indifference curves. You just plot all the points of uxy such that uxy is a constant k. Actually, it is the equation of an indifference curve. Given a bundle, it is easy to draw indifference curves. You simply identify all the points of x and y such that uxy is a constant. In the language of mathematics, the set of all xy such that the set of all xy such that uxy is a constant is known as level set. The set of all xy such that uxy is a constant is known as level set. Suppose that a utility function is given as uxy is equal to simply as x into y. A utility function is given uxy is equal to xy. Remember this, if preferences are given, indifference curves can be drawn associated with the specific preferences. What we are doing now is, if a utility function is given, we can again derive the indifference curves. This is the procedure that I am discussing. So a utility function is given. Now the question is, what will be the shape of the indifference curve associated with this utility function? What will be the shape of the indifference curve associated with this particular utility function? And we know that a typical indifference curve is the set of all xy such that k is equal to xy, such that k is equal to xy for some constant k. A typical indifference curve is set of all xy such that k is equal to xy, a constant. So solving for y, we can write it as y is equal to x by k. X by k, and such an indifference curve or set of indifference curves is given here. Y is here, x is here, and k is equal to 1, k is equal to 2, k is equal to 3, like this. Y is equal to kxy. We have the curves represented by y is equal to x by k for different values of k. So solving for y, the indifference curve has the formula y is equal to x by k and its graphical representation. Suppose that vxy is equal to x square y square. Vxy is equal to x square y square. Now the question is, what will be the shape or how the indifference curve will be given that the utility function is x square y square? We know that Vxy is equal to x square y square is equal to xy the whole square is equal to u of xy square. Xy square is equal to u of xy square. So the utility function Vxy, the utility function Vxy is nothing but the square of the utility function Uxy. Uxy is equal to xy. The square of this xy is xy square or x square y square, and so it is nothing but Vxy is x square y square is equal to thus u of xy square. So it is nothing but the square of uxy is equal to xy. So the utility function Vxy, the utility function Vxy is nothing but the square of the utility function Uxy. Utility function Vxy, x square y square is nothing but the square of Uxy, that is xy. Since Uxy cannot be negative, it follows that Vxy is monotonic transformation of the previous utility function. So Vxy is the monotonic transformation of Uxy. So the function Vxy equal to x square y square, as it is a monotonic transformation of Uxy is equal to xy, Vxy equal to x square y square produce the same shaped indifference curves as uxy is equal to xy. So the shape of the indifference curve generated by this utility function will be identical to this one, except that labeling of indifference curves will be different. In the original case it is 1, 2, 3. In the new case it will be 1, 2, 3 square 1, 4, 9, because it is the square of Vxy is the square of Uxy. Vxy is the square of Usy. That is it. So the shape of the indifference curve will be identical. The only difference is the labeling is different. Also remember this, Vxy is a monotonic transformation of Uxy. Now the set of bundles that has say Vxy is equal to 9, the set of bundles that is Vxy has number equal to 9 will have a corresponding Uxy with a number equal to 3. 3 will be relabeled as 9. So both describe the same set of preferences. As order of the bundle, ordering is identical. While discussing utility function, we have discussed about monotonic transformation. Remember this, utility is defined only in the ordinal sense. So, and if an original utility function is given, a monotonic transformation, order preserving transformation will also serve as the utility function, because only order is important, magnitude is not important. So if a utility function is given like this, we can always derive the corresponding indifference curves. But remember also this, indifference curves can be derived if preferences are given. That is, indifference curves can be derived from what is the from preferences. That is, you can associate a specific indifference curve to a specific preference. We can also associate indifference curves if utility function is given. If utility function is given, it is easy to derive indifference curves. And this is what we do. And in the subsequent sections, we will describe the shape of indifference curves associated with the different utility functions, different types of utility functions. So remember the point, from preferences, indifference curves can be derived. That is one procedure. The second is, from utility functions, indifference curves can be derived. The second procedure is easier than the first procedure. And remember also this utility function is monotonic, order preserving. So if an original utility function is given, a monotonic transformation also serves as the utility function. That is, one set of numbers can be transformed into another set of numbers, and the only requirement is it will be order preserving. So 1, 2, 3, 1, 4, 9, order preserving. 3 is greater than 2, greater than 1, 9 is greater than 4, greater than 1, like this, order preserving. So if uxy is a utility function, then vxy, x square, y square is also a utility function, because vxy is obtained by a monotonic transformation, that is squaring of xy. Squaring of xy, as we have discussed earlier, is a monotonic transformation. So in the next classes, we will discuss specific type of utility functions and associated indifference curves.